So I'm going to make homework tonight, and it will be on Canvas. Of course, you'll have at least a week to work on it. Let's get started. Okay. A graph that consists of a single piece or component is connected. So of course, the pieces in your graph are going to be numbers you can count on your finger, 1, 2, 3, 4, 5, 6, and so on. If there's one piece, it's connected. If there's 2 pieces, 3 pieces, any more than one piece, it's called a disconnected graph. So connected, one piece, disconnected, more than one piece. Okay, let's do an example for connected. Okay, this graph is connected. It is only one piece. There are 3 vertices, 2 edges. It's okay that it's not closed. It's just a little, kind of arm connected to another arm. It's a connected graph with one component. Okay, we want something disconnected. I will draw, let's see, the first component as a diamond. Then we'll go over here and do a dot with a loop. And let's go to the side and again. And we're gonna add an extra edge right there. So remember, that's a loop. These are multiple edges. And there's more than one edge between 2 vertices. Okay, so it's disconnected. It has 3 components. And now we practice. So I want to jump back to working with finding the degree of each vertex. And also we're going to list how many components. So the graph is a single piece. So it's going to have one component starting here, and let's go up, kind of like a triangle, and one more. 4 vertices. We're going to make a triangle between these. Another triangle on this side like that. And then I made it look sort of like a heart. So we're going to go hook and hook. This is G, F, H, E. So degree of G. B, degree of G. Is the number of edges that connect to G. So we're going to shade that in. 1, 2, 3, 4, 5 connections. Let's get the degree of F. F has degree 3. Right, H also has degree 3. And E, degree 3. There is one component, which means this is a connected graph. Okay, so for the next one, we're going to just label every vertex with the degree and list how many components. Okay. Cool. So let's get that graph. We'll start on this side with vertex that connects to another. And go over and draw a vertex with a loop. Let's just do another loop and another loop. Let's move over, draw a triangle. We're going to put 2 dots to the sides like this and connect to those bottom 2 vertices of the triangle, both of them. That's going to be it for the graph. Let's do the degree first. This would be degree 1, degree 1. A loop adds 2 to the degree, so it says 1, 2, 3, 4, 5, 6. Degree 6 right there. Let's put it as that. And we're at degree 2, degree 2, degree 2. This will be 1, 2, 3, 4. 1, 2, 3, 4. Degree 4 for each. So we're done with the first part. How many components? There are 3 pieces, which means there are 3 components. And let's try one more like this. Same instructions. Label each vertex with its degree. And find the number of components. Start drawing a graph. And let's do a vertex that has like 4 connections. Those vertices, we're going to draw an edge between them. Moving over, let's make a let's make a triangle like this. There needs to be a vertex there. And we're going to come over here and like this, like that. All right, that's good enough. Next part. I'm going to draw a dot, and then I'm going to draw a dot, and let's do a loop with let's just stop there. Okay. So that's the end of the graph, and we're going to start labeling all of the vertices, vertices with their degrees. This is degree 1, just one edge connecting. Same here. Degree 1, 2, 3, 4. I just want to highlight. This is degree 2. 1, 2. Same here. That's for the first component. Second component. This part has degree 2. This is degree 2. Degree 1, 2, 3, 4. 1. 1. Okay. No connections to that vertex, which means you have a degree 0. And that happens there, degree 0. This one's got a loop, so it's got degree 2. We've done the degree of every vertex, and I think we're on to components. Let's count them first. 1, 2, 3, 4, 5. 5 components. Disconnected. And let's see, maybe one more, and then there's a theorem, and a theorem kind of summarizing some of the stuff we've learned, and some word problems to do. Same instructions. Label each vertex with its degree. And find the number of components. So we're going to make a, let me make sure I do a good picture. So close. And that is kind of an X shape. It goes like this, here, to there, back. Okay. We're going to add an extra triangle here. Put a vertex there. And then we're going to put a loop. Put it over here. And then I have, from the one with a bunch of loops on it to this corner over here, we're going to put an extra edge right there. And I put an extra edge between the one with loops and this vertex. That's the graph. So first we're going around to each vertex and finding the degree. That's got 2 connections, so it's degree 2. This is 1, 2, 3 times, it's degree 3. 1, 2, 3, 4, degree 4. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So yeah, 1, 2, 3, 4, 5, 6, and each loop adds 2. 6, 7, 8, 9, 10. And this last one's got degree 3. It's one component, which means it's connected. So I think that the theorem is at the bottom. These notes. Cool. So the number of edges the number of edges is equal to half of the sum of the degrees, half of the sum of all of the degrees. Okay, so that means you would find the degree for every vertex. Add every degree, like all of the degrees together, and divide by 2. And that is going to give you the number of edges that are in the graph. Let's do an easy one. So let's try. Let's just do a triangle. There's 1, 2, 3, and back. It's degree 2. Degree 2. Degree 2. So sum of all of the degrees would be 2 plus 2 plus 2. Okay, if we take that number and cut it in half, it tells us how many edges there are. So number of edges is, let's write it out first. Cool. So we got 8 divided by 2, and that's going to be 4. And a second, there's my mistake. 1, 2, 3, 4, 5, 6. 6 total. So that means we have 3 edges. Like number 1, number 2, number 3. Okay, we're going to move on to those word problems I mentioned. And first one has 2 teams of 5 people. Everyone on each team is going to shake hands with everyone on the opposing team. But no one from their own team. So, how many handshakes occur? Okay, so at the end of class, I have a way to sort of create a sum of the degrees without drawing a graph, but we're going to practice drawing graphs. There's not like a for sure formula for every problem. Some problems have formulas, but I think it's best to just draw a graph for each of these kinds of word problems. Okay, this one, we have two teams of 5 people. I'm going to use blue for like blue team with 5 dots. And then we'll do orange, like orange team. Each needs 5 people. Let's do it like these guys are here. 1, 2, 3, 4, 5. And then there are 5 people on the orange team. And each person from the team shakes hands with everyone on the other team. So let's start with this person. They do the first handshake and go down the line and meet with everyone from the blue team. This person does the same thing, connects with each person from the blue team once. And keep on going. Third person from the orange team shakes the first person's hand, the second person's hand, the third person, and so on. Then we go and greet the first person, second, third, fourth, fifth. This last person needs to shake hands with each of the other team, each of the blue team. Okay, so everyone's gone through, and now we're going to find the degree for each person, or vertex. This will be a degree 5. 5's all the way. Each person had 5 handshakes, or 5 connections. Same for the blue team. We're doing some work outside, so apologize for this noise, but it's just like a little bit. Okay, so the sum of all of the degrees is going to be 5 plus 5 plus 5 plus 5 plus 5, and add all these 5s together too. So we're going to have 5. We're going to have 50 total. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50. But we want to know how many connections happened, how many handshakes were made. So number of edges is 50 divided by 2. Okay, so the next problem, we're going to start a whole new graph and just redraw everything just in case. We will have 5 people sitting at a table. Each person shakes hands with everyone who did not sit next to them. Okay. Each person shakes hands. With everyone who didn't sit next to them. Yeah. Okay. How many handshakes occur? Cool. So we're going to put these, we're going to draw 5 vertices representing our 5 people. And I'm going to put them in sort of a circle. So they're sitting at a round table. Two, three, 4, 5 people. Okay, so just pick a person. Like, we're gonna pick this guy. And we do not shake hands with people who sit across from us or like right next to us. So we're gonna go and skip this and go here and not there. Okay. This next person does not want to shake that person's hand or that person's hand, but we can go to the other 2. And this person can't connect with this person or that person, but can go across, which we've already done right there, but we can make this connection too. I'm just going to keep checking. So for here, we're not going to connect to the people right next to us, but we can have those connections. And just last one, we don't connect to either of those people, but we can connect with them. And then we're back where we were. So let's get the degrees. This one's a 2. That's a 2. They're all 2. So the goal is to find the sum of the degrees and then divide by 2. we have 2, 4, 6, 8, 10. The number of edges is the sum of degrees divided by 2. It's going to be 5 edges, 5 connections. And this time, the connection is a handshake. And let's keep on trying some of these. So we're doing one more example. It has 4 parts, and that will be the end of, that'll be the end of lecture once we reach the last part. Some attendees at a convention connect with each other by exchanging cards. Single word. Connect with one another. What's the difference? Business cards. And if 2 people exchange their cards, they've made a connection. How many cards are exchanged if, and then we'll do the first part. Cool. Part A. We have 6 people, each end up with 3 new cards. We're going to draw a graph that kind of represents the situation. Once we have a good graph, we'll find the sum of the degrees and divide by 2. That will give us the number of edges, or the number of cards. Oh wait, okay, we're here. 6 people. Let's draw them in a kind of a circle. Each gets 3 cards, so each vertex has degree 3. This will be 1, 2, 3. And I've done this problem before. Sometimes the graph is tricky to draw, so I'm going to sneak a peek at my answer key. But just to let you know, sometimes graphs can take a little while to get all of the right connections. Okay, we have another 3, starting here. 1, 2, 3. This person already has 1 card, and they're going to go to that vertex and that vertex. So I've got another 3. And this vertex is going to go, I've already got 1 connection. It's going to go here. Wait, we've already got 3. Thanks. It needs to stay at 3. Mm-hmm. Thinking, should I start my graph over or just try to make it work? I'm going to see if I can make this one work. So this already has degree 3, and that's a degree 3, and that's a degree 3, and this would be degree 3. We connect here, we'll have a problem. I'm going to try to redraw. Okay. 6 people. And this graph would go, let's see, down, down, down. That's degree 3. This would go here and here. This one has already got 1 connection, and then up to that vertex and over. So 1, 2 connections, and then this will make it 3. I think we just connect from here to here and be done. Yeah, that's 3. That's 3. So first we're going to talk about like looking at the graph. Now that we have a graph that works for this situation, the sum of degrees is 3 plus 3 plus 3 plus 3 plus 3 plus 3, which would be 3 added to itself 6 times. And that's also the same as having 6 times 3. So you can just add like 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. But I've got this here so that you know that 6 people, 6 is the number of vertices, and 3 cards each, so the degree for each. Okay, so 6 represents the number of people. Or vertices. Okay. 3 was for how many cards each got. Which would be how many edges connected. Or actually, you know what, we're gonna put that gives us the degree. So it's the degree 3 for the number of cards that you get. and it happened 6 times for each person. Okay, we still need to do more work. Take that number and divide it by 2, and that will give you the number of connections, or the number of cards. Cool. So we're going to go on, and part B has 2 people each get 4 cards, and then 4 people who each get 2 cards. Let's see the number. Okay, I'm going to try to write out the sum of degrees first, and then we're going to piece together a graph. So the sum of degrees should be equal to 4 people, or 4 vertices, and then each of them has degree 2. Each of them got 2 cards. So 4 times 2. Add the sum of all of that. 2 people, or 2 vertices, have degree 2. So 2 times 2. 8 plus 4 will be 8 minus 12. Cool. So we're going to start to draw now. We're going to draw 4 vertices for the 4 people that we start with. Okay. And actually, I'm going to put them more side by side. And then there's 2 other people who get 2 cards. Put them down here. So earlier I was talking about this was for people. And this was the number of cards that each got. And people. 2 people got 2 cards. Okay, so for those 4 people who get 2 cards each, we're going to go like this. Meet with those 2 people on the bottom. Same for that person, and that person, and that person. And it just so happens by doing that, those people down here met with 4 people each. So we've got 2 cards for degree 2. Degree 2. Degree 2. Okay. This person met 4 other people, which means it has degree 4. And degree 4. So one more time, that this part, this first term, is those 2 people. Wait. I think I may have this. I have this backwards maybe. have these mislabeled. Oh man. What was I thinking about this before? When we read the problem, it says 2 people get 4 cards, so 2 vertices with degree 4. We wanted 2 on the outside and 4 on the inside. 2 people each got 4 cards. And then 4 people who get 2 cards. Oh, okay, I had the wrong numbers. 4 people get 2 cards. So that was supposed to be 8 plus 8. And we get 16. Let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I had a mistake. But let's go back to making sure we have the right graph too. So this person has 4 connections, or 1 vertex with degree 4, another vertex with degree 4, and there's our first term. There's 1, 2, 3, 4 vertices with degree 2. That's our 4 people, and then each had degree 2. Okay, everything's all pieced together correctly, but we need to get the number of edges. It's kind of messy. We want to take 16 divided by 2 and get 8. Eight new cards. Cool. We're going to make it through part C and then talk about kind of a weird situation in part D. You know what? I need all that stuff. Okay, so in this example, it's part C. We have 3 people get 4 cards. Two people get 3 cards. Last part. 1 person gets 2 cards. Let's put this over and I can draw the graph on the side. Oof. Okay. Let's see if I can think through the sum of the degrees, but we are going to actually draw a picture, draw a graph. Okay. So each person's going to be a vertex. So I'm going to have 3 vertices, 3 dots somewhere. Each of them has degree 4. So we're going to do 3 times 4. vertex/person. 4 represents the degree or number of cards that person got. And then add, sum. This part, 2 people get 3 cards. So somewhere in my graph, I've got 2 vertices, and each of them has 3 edges connected, or degree 3. Vertex and degree. Add, because we're just finding the sum of all of the degrees. The last part, you've got 1 person who gets 2 cards. So there's a vertex with 2 edges connected. Somewhere. Okay. Let's see, that would be 12 plus 6 is at 18, and then 19, 20 for the sum of the degrees. So I did draw a graph to help picture what's going on. There are 3 people, 2 people, 1 person. So we're going to start with the 3 on the top. And then 2 more people. And then that last person at the bottom. These 3 people each got 4 cards. So 4 connections for those vertices. I drew it down, over, actually I did this one too, all the way to the bottom, and then to the top. And I went to the other side and did a similar connection to the top. Skip this guy and go here. Here, here. 1, 2, 3, 4. And then connect here and here. And what's left over is a vertex on this side with degree 3. This has degree 3. And the bottom has degree 2. So we've got our 3 people who each got 4 cards. Those are the 2 people who got 3 cards each. And that last person who only gets 2 cards. So we'd add all of the degrees together. 4 plus 4 is 8, and now we're at 12, 13, 14, 15, 16, 17, 18, 19, 20. So that was good. But we want to know the number of edges that we have. So take that total and divide by 2. And I think I want to highlight. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's good. Just went over every single edge one time. Okay, so the last question is kind of a trick question. So we're going to say, what's wrong with the following situation? one person gets 4 cards. And 2 people get 3 cards each. Two people get 2 cards. And one person, oh no, 2 people get 2 cards and 1 person gets 1 card. 1 person got 1 card. So what we're going to do is write out the sum of the degrees. Each person is going to represent a vertex, and each card is going to be the degree of that vertex, and we're adding everything together. So take the number of vertices, multiply with the degree for each. So we'd have 1 vertex with degree 4, and then 2 vertices that have degree 3. 2 vertices, 2 people, have degree 2, and that 1 person with degree 1. That's the degree. Okay, so 4 plus 6 plus 4 plus 1. That would be 10 plus 4 is 14, 15. And then take 15 and divide by 2. So the number of edges. 7.5. Okay, and then there's a problem with that 0.5. So there would be 7.5 edges. Or connections. But you can't have half an edge. You can't have half a handshake or half of a connection. It's either a full connection or no connection. Okay, so that's the end. Yes. And I'll be posting homework tonight.